Hi everyone. So in this session, we are going to see how to study for the board examination on the topic periodic classification of elements. So this topic from the chemistry part from the science 10th chapter, class 10th science topics. Okay, under the one of the science topic from the chemistry part. Okay, now we'll see how to study for the term to examination. Term to examination. Okay. So I will cover this total chapter in the two parts. Okay. So from the first part, we are going to cover up to the Mendeleev's periodic table. Okay. We'll see the content plus what are the different questions they will ask from the each topic. Okay. Like a Dobenier triad, we'll see how they will ask question from the Dobenier triad. We'll see same way Newland periodic table will cover. From that, how they will ask questions. We'll check the some questions. Okay. Now, next, the third important topic is Mendeleev's periodic table. So from that also we'll see some questions, how they'll ask questions from the topic also. We'll cover topic by topic. Okay. In the second part, we'll see the modern periodic table. Why? Because they will ask me more questions from the modern periodic table. Okay. So that's why I will do a separate slide over the modern periodic table separately. Why? Because some extra topics are there. So here more topics, but important topics are less from these three topics. Okay. So in this first slide, I'm going to cover the three topics. Along the three, first we'll see the features of the three topics. So along that, I will solve some questions from that particular topics. Okay. Now, so first we'll see what are the topics under the periodic classification of elements. Okay. So this topic is very, very important. So from this topic, you will get a 2-mark question, one 2-mark question, and one 3-mark question. In the 3-mark question, you have internal choices. Okay, so they given an internal choices from the from 3-mark questions. Okay, and these 2 and 3-mark question they're asking in terms of 1-mark question, like 1-mark question A and B. Okay, they're not asking the very long question. They're asking like a B, C, D questions. So like that A, B, C. That means each question carries a 1 mark. And finally, they'll carry the 3 marks. Like that, they're asking question. Or they're giving one statement. From the statement, they're asking the A, B, C, Ds. So we have to give reason type questions. Predict the following questions. Okay. So this type of question, we'll see the questions also, how they're asking the questions from this topic. Okay. And first we'll see what are the topics under this topic. Okay. So from the periodic classification of elements, if you see the topics, these are the topics. Okay. So that we need to cover from this chapter. Okay. That is, so here there is no deleted portion for academic year. For academic year 2021 to 22, there is no deleted portion. Okay. For term 2 examination, there is no deleted portion. We need to study every topic from here. Okay. So this is the topic that we need to study. One is periodic classification of elements. So first one is Dobenier triad. Another periodic classification. First topic is Dobenier triad. So here we need to study the features of the Dobenier triad. So along the limitations of the Dobenier triad, we need to cover here. Okay, this is the first topic. And second topic is Newland's law of archetype. Here also we need to study the features plus limitations. So the features and the limitations. Limitation. This is the topic we need to cover here. Next, the same third topic is so Mendeleev's periodic table. This is one of somewhat big topic when compared to the Dobenier triad and Newland's law of archetype. Okay. So under that we need to study what are the main features of the features of the Mendeleev's periodic table and achievements of the Mendeleev's periodic table and the limitations of the Mendeleev's periodic table. It is somewhat bigger topic when compared to the Dobeniers and Newlands. Okay. So we need to study the features of the Mendeleev's periodic table, achievements and limitations. Okay, we'll cover that also. Next, fourth important topic that is. So this is from here they are asking more number of questions. Okay, out of 2 and 3 mark question, so one question confirmly will get from here, from the modern periodic table. Okay, and 2 mark question maybe from the Mendeleev's periodic table or Dobenier triad or Newlands. Okay, but this 3 mark question, they're asking mostly from the modern periodic table. You should be thorough with the modern periodic table. Okay, so under the modern periodic table, we need to study the features features of modern periodic table. Okay, here there are no limitations. In the modern periodic table, there are no limitations are there. So we need to study the only features. Okay. So along that, we need to study the position of elements in the periodic table. Okay, the very, very important topic. Next, trends. Trends in the modern periodic table is a very, very important topic. So under the trends in the periodic table, under the trends in the modern periodic table, so we need to study three topics. That is, one is valency. Valency is the one of the important topic. From here, they're asking question. Next one is atomic size. Atomic size. Second topic. And third topic is metallic and non-metallic nature. Metallic and non-metallic nature. Non-metallic nature. Okay, the third important topic. Okay, so these are topics that we need to cover from our modern in the periodic classification of elements. Okay, we'll see one topic by topic. Okay, so along that, by covering each topic, we'll see the some of the how they ask questions from the for the board examination. We'll see that also. Okay, next we will see the first topic. So in this slide, we are going to cover the first three topics. Okay, so after the three topics, in the second slide, we'll go completely with the modern periodic table. Modern periodic table. Okay, so when you see the first, we'll see the first topic. We'll go with the Dobenier slide. Already I covered one topic over this. Okay, just I will revise once. Okay, what is the Dobenier slide? Okay, is the first periodic classification. Okay, that means official one. Okay, the first official periodic classification. Okay, now, so the Dobenier slide is one of the important topic. Okay, so from here also we're getting some questions. Okay, now, so Dobenier. So first we'll see how we arrange. Okay, so Dobenier arranged the elements with similar properties in a group. Okay, just he made a group. Okay, so he took the elements and made a group which are having the similar properties. Okay, this you have to keep in mind. He grouped the elements which are having the similar properties. Okay, and similar properties. Okay, now second thing. So he identified three elements. So just he identified some groups having the only three elements. To that elements he kept one name called as that group he called as a triad. Okay, the one. Next important feature here. So Dobenier shown that three elements in a triad, when the three elements in a triad, atomic mass of the middle element is equal to the average of the first and third element. This is the important one. Okay, he shown that among the group of elements, okay, the element which having three elements in the group, that means in a triad. So he shown that atomic mass of the middle element is equal to the average of the first and third element. Okay, so just he arranged only three triads out of the known elements. Okay, just he arranged only three elements. Okay, that is three. He made only three triads. Okay, where is the lithium? So first triad is lithium, sodium, potassium triad is the first triad. Okay, so and also shown that so here in the elements in the increasing order of atomic mass. Okay, so lithium atomic mass is 7 and sodium atomic mass is 23 and potassium atomic mass is 29. Okay, here in like a increasing order of atomic mass at the same time. So this element possesses same properties, similar properties. Okay, and also shown that atomic mass of the middle element is average of the first and third element. Okay, you see the average of first and third element, that is 7 plus 39 by 2. So if you see the average, that is equal to approximately equal to 23. Okay, so this atomic mass is equal to the middle element. So this is the shown. Okay, is the main feature of the Dobenier triad. Okay, so next the second triad is calcium. Okay, strontium and barium is the second triad. So here also just arrange the elements with this which possess the same properties in the increasing order of atomic mass. Okay, these are the atomic masses. Okay, atomic mass, and also shown that atomic mass of the middle element is equal to the average of the first and third element. Okay, you see the average around 88.5. Okay, so it is equal to the average of the So this average equal to the atomic mass of middle element. Okay. So the next third triad is chlorine, bromine, iodine. The third triad. Here also, here in the increasing order of atomic mass. So atomic mass of chlorine is 35.5. Atomic mass of bromine is 80. And atomic mass of iodine is 127. Okay. Now, so and also shown that atomic mass of the middle element is equal to the average of the first and third element. First element atomic mass is 35.5 plus next third element mass is 127. Okay, its average is equal to around 81.25. Okay, so this average is equal to the atomic mass of the middle element. Okay, so just he made only three triads. Just he made only three triads. Okay, you may ask those, sir, why can't we arrange fluorine, bromine? Why can't arrange halogens like a fluorine, chlorine, bromine? Okay, so actually, so this is, we can't arrange the elements in a triad, and we can't show this also. Okay, so when the elements having the very low and high atomic masses, okay. So if you see the, already we know chlorine atomic mass is 35.5 and bromine atomic mass is 80. Okay, if you see the fluorine atomic mass, atomic number is so 9, that is around 18. It have a 18 atomic mass, around 18. Sorry, around 18 atomic mass, that is 19. Okay, atomic mass is around 18 atomic mass. Okay, so when you see this, atomic mass of the first and the third element is not equal. Around you will get a, so 98 you will get. Okay, so if you see the average of the first and third element, that is around 40, you can get around 46. Okay, around 46. Okay, so this, you see the average here 46, but it is not equal to the, not approximately equal to the middle element. Okay, so we can't arrange this fluorine and chlorine, bromine in the form of triads. Okay, why? Because it is not applicable to the element which possesses very low atomic mass, very low atomic atomic mass and high atomic mass. So to that elements, we can't arrange them. Okay, so this is one of the limitation. Okay, at the same time, there is one more limitation there. So just arrange only three triads. Just arrange only three triads. Around 32 elements, just arrange. So at the time, known elements are around 32 elements. So out of 22 elements, just he made only three triads. That means he arranged only 9 elements in the form of triads. Okay, so remaining elements he are unable to arrange. Okay, stop. So this is the topic of the Dominier triad. Okay, now we'll see some of the questions. How? So they'll ask questions from this topic. Okay, now I think you clear with this topic. Okay, now we'll see some questions over this. Now just remember the topic. We'll see some of the questions. Okay, so just arrange the grouped elements which are having the similar properties. Okay, next he identified 3 elements in the group. We called that group as a triad. Okay, so in a triad, so average atomic mass of the first and third element is equal to the middle element, atomic mass of the middle element. Okay, now we'll see some questions from here. Okay, now so here we have one question with us. Okay, so this is the way they will ask question to the board. Okay, now see here. So here now, so 3 elements they given like this. Okay, they are not specified the names here. So 3 elements A, B, C. Okay, so with the similar properties, having atomic mass X, Y, Z, these are atomic masses respectively. Okay, the mass of the Y, the base middle element, is approximately equal to the average of the X and Y. That is the first and third element. First atomic mass of the first and third element. Okay, so what such arrangement of elements we can call? We can call as triad. Okay, so that arrangement, what we can call as? We can call a triad. 3 elements in one group with similar properties, and also atomic mass of the middle element is equal to what? Average of the first and third element. Okay, next. and give one example of such set of elements. Okay, already we have a three triads. You can give any one example. Okay, you can give the anyone. You can give any one example from here. Okay, you can give. So we have a lithium. So we have a one triad like a so lithium, sodium, potassium triad. You can give. Okay, or also we can give a other, that is next one. We have a next triad, that is a chlorine, bromine, iodine. This triad also we can give. Okay, so also you have to show that. So atomic mass of middle element equal to the average of the first and third element. Okay, this is the way you have to answer this question. Okay, now we'll see one more question from here. Okay, so you see one more question here. So can the following group of elements be classified as a bromine triad? So here they given a two set of elements with three elements. He given a two set of elements with three. Okay, you can see here sodium, silicon, chlorine. Okay, and beryllium, magnesium, calcium. Beryllium, magnesium, calcium. Okay, now, so can the following set of elements can be classified as a triad? They're asking whether we can able to make them in the form of triads. Okay, so what is the first feature of the bromine triad? So the element which we are going to group, they should have a similar properties. Similar properties. Okay, you check here whether this. Suppose we take this set of elements, whether they are elements of the same properties. No, sodium is the different, silicon different, and chlorine is the different. Okay, so they may have a different properties. Yes, they have a different properties. Okay, that is the first feature of the bromine triad. Only we have to group the elements which are possessing the same properties. Okay, so this element do not possess same properties. Okay, here they give the atomic mass. Okay, you see the atomic masses. Okay, now we'll see this sodium, silicon, chlorine. Okay, sodium atomic mass is 23, silicon atomic mass is 28, and chlorine atomic mass is 35. They can like, okay. Now see, we check. Actually, we can't arrange them. Why? Because they don't have a similar properties. Okay. Now, you see the average. Okay. You see the first and third element average, that is around 58. 58. Okay. Silicon is 58. Okay. At the same time, okay, you see the average of this one, you get around 50, so 24. 24. Okay. See here. So average also not equal to the average also not the average of the first and the element not equal to the silicon. Okay. So this set we can't make them as a triad. Okay. Reason number one. So reason number one is okay. So this element, okay, this element do not possess same properties. Okay, they are different properties. Okay. Now see already given atomic mass of sodium is 28, silicon is 23. Next, you will see the silicon. Okay, 28. Okay, and chlorine is 35. Okay, average also not equal to. Okay, next. What about the next set? You see the next set. That is, you see the beryllium. Atomic mass is 9. Okay. Next, magnesium. Atomic mass is 24. And calcium. Atomic mass is 40. Okay. So actually this element, they possess similar properties. Beryllium, magnesium, calcium. Okay. So they'll possess similar properties. Okay. And we can, and average also, this is the average of first of the, is approximately equal to the, okay, that is 9 plus 40 by 2 is equal to 49. It means you will get around 25. 49 means it's around 25.5. Okay. So approximately maybe very near to the magnesium. Okay. So this mass is very near to the, so magnesium. Okay. 49, that is, sorry. Yes, 44.5. So we'll get a 44.5. Okay, so approximately equal to the, so magnesium. Okay, this set we can able to arrange. Why? Because they will possess it, same properties. So beryllium, magnesium, calcium, they will possess similar properties. This we can able to. Okay. But so this set we can't make. This set, sodium, silicon, chlorine. This we said we can't replace. Okay. Yes. So this set we can able to arrange. Okay, second set we can able to arrange in the form of Dobenius triad. The first set we can't arrange them. Why? Because so they, that element do not have a similar properties. Okay, we can't arrange them. Okay, so first set we can't arrange, second set we can arrange. Okay, and also they are following the Dobenius triad laws. Okay, so atomic mass of the middle element is approximately equal to the average atomic mass of the first and third element. Okay, second set we can able to arrange. First set we can't arrange. Okay, so like this type of questions they may ask uh, from the first topic, okay, so be thorough with this type of questions. Okay, now, so this is the topic, how we need to study. Okay, so most they'll ask questions like by giving the example like this. Okay, or try to practice some questions like this. Okay, you can score a very good marks in the board examination. Okay, now same way we'll see the second topic, that is Newland's law of active. Newland's law of active. Okay. Now, this is the next topic, that is Newland's law of active. It is also one of the important topic, and also we'll see some questions. How we'll get a question from here. Okay. Now, so from here you can expect very less number of questions. Okay. Just we'll see here. Okay. So Newland's law of, this is the second topic. The second topic of the periodic classification of elements. Okay. Newland's law of active. So here, so by to overcome from the limitations of the Dobenius triad, so this chemist just arrange the elements in the increasing order of atomic masses. So known elements, just he arrange the elements in the increasing order of atomic mass. Okay. He started with hydrogen. Okay. So for the light element, okay, lightest element. So hydrogen, and ended with the thorium. Okay, just ended with the thorium. That is the 56 element. That means he arranged around 56 element. Okay. Next, he found that. So what are the next is the one more important feature. He found that every eighth element had a property similar to the first element. This is one of the important feature of this Newland's law of active. He found that so every eighth element, while arranging the elements in the increasing order of atomic mass, he found that every eighth element properties had a similar properties like first element. That means if you see the lithium, okay, so if it's a next eight element is first element, 2, 3, 4, 5, 6, 7. This is the eighth element. Okay, so sodium and lithium, they have similar properties. Okay, so you can, it's like this. Okay, just he found that. Okay, and he compared, so this similarity with the octave found in the music. That is sa, re, ga, ma, pa, da, ni, like this. Okay, so after ni, once again what will come? Sa will come, like that. Just he compared with the musical notes in the 8 musical notes in the music. So that's why his law is called as a law of active. Okay, and also named as a Newland's law of active. Okay, with the main features. Okay, so just here, here in around 58 elements, from starting from the light elements hydrogen to the thorium. Okay, next, though here, but so many limitations are there. There are some limitations. The first limitation. So whatever he law is there, that is the Newland's law of active, is applicable only up to the calcium. The law of activeness is applicable only up to the calcium. Is the first limitation. Okay. So Newland law of active is applicable to only up to the calcium. Is the first limitation. Second limitation, you can see here. So in order to in order to keep the elements in the same groups, in order to keep the elements in the group of similar properties, okay, in order to keep the elements in the same group under the same set of groups, okay, which are having same properties, okay, just he kept the two elements in the same group. You see here. So in order to keep in the group of similar properties, just he made it two elements in the one slot. See here. So cobalt, nickel he kept in the same, and cerium and lanthanum he kept in the same group. The one drawback number 2. Okay, and so he felt that there is only 56 elements in the nature, but later on so many new elements are discovered. So that elements are unable to fit in the this Newland's law of acting, unable to fit in the his periodic table. So these are the three limitations, are the important three limitations. The limitation one is, so law of activeness is applicable only up to the calcium. Okay. So in order to keep the elements in the similar properties, in order to keep the elements in the similar property group, like in order to keep the elements in the group of similar properties, he kept two elements in the same group. The limitation number 2. Third limitation. Okay. So he felt that there are only 56 elements in the nature, but later on so many elements are discovered. So that newly discovered elements are not fit in the, they are not fitted in the Newland's law of active. These are the main features. Okay, with the main content. Okay, next we'll see how they will, how they will ask questions from this topic. Okay, so first remember what are the main content features of the Newland's law of active. This next we'll see how they'll ask questions from this topic. Okay, next we see some questions from here, how they ask. Okay, now we'll see the questions from here. Now we see questions here. Okay, we have a question with us now. So here we will expect a less number of questions. Okay, now or sometimes they may ask draw the limitations, write the limitations of the Newland's law of active. Okay, now so up to which element, like one more question, so keep a say up to which element the law of active was found applicable. So already we know this is up to the calcium. Okay, so up to calcium law of activeness is applicable. After calcium it is not applicable. Okay, so here we can expect less number of questions. Okay, so more number of questions we can expect from the Mendeleev periodic table, at the same time modern periodic table. So maybe expect one question just okay, just to go through the law of activeness, Newland's law of activeness. Okay, next we will see the next topic, that is very important topic. Third topic of this chapter is, that is Mendeleev's periodic table. Mendeleev's periodic table. Okay, we will see the next topic, that is Mendeleev's periodic table. First, we'll see the content first. Thereafter, we'll go with the questions. Okay. Now, Mendeleev periodic table. So after the Newland's periodic table, to overcome the limitations of the Newland's periodic table, so new periodic table came forward. That is Mendeleev's periodic table. Okay. So this periodic table mainly based on one law. Okay, is the main law of the Mendeleev periodic table. Okay. So the properties of elements are periodic functions of the atomic mass. That means, so just arrange the elements in the increasing order of atomic mass. While arranging the elements in the increasing order of atomic mass, he found that the properties will repeat with the periodic time. Okay, the properties will repeat in a particular interval of time. Okay, now just arrange the elements in the increasing order of atomic mass. Okay, so just you can see so Mendeleev's periodic table. Okay, so here you can see the groups and columns. Okay, the horizontal rows he called as a periods, and vertical columns. These are the vertical columns. Okay, this is the vertical columns. You can see the vertical columns here. Okay, this vertical columns he called as a groups, and horizontal rows he called as a period. These are the periods. You can see here the periods. Okay, so in this period, just arrange the elements. Okay, so while arrange the elements, he grouped the elements. Just while he arranged the elements in increasing order of atomic mass. At the same time, he grouped the elements. How they will show the reactivity toward the, suppose he grouped the elements which show similar reactivity toward the oxygen and hydrogen. So that element they kept in one group. Okay, that means, so whatever you see in this group, like a hydrogen group, they shows, they produce or they give similar type of oxides and hydrogens. Okay, for example, you take the lithium and sodium. Why kept in the same group? Simple. So this will show, this will give a similar type of oxides and hydrates. Okay, both will give a, so Li2, that is R, both will give a R2O type oxides and RH type hydrates. Okay, all elements, what you see the elements, whatever they are in this group, they will show, they will give a similar type of oxides and hydrates. So that's why he kept in one group. Okay, he grouped the elements, okay, which will give a similar type of oxides and hydrates. Okay, same way, if you see the carbon family, okay, so under the carbon, okay, so all these group elements, they will give a similar type of oxides and hydrates. Okay, so carbon will give always, will, if this thing, carbon, silicon, germanium, so next element, tin, lead, this they give a similar type of oxides and hydrogen hydrates. Okay, so that elements only he made one group. That elements only he made one group. Okay, here in elements in the increasing order of atomic mass. At the same time, he grouped the elements which will possess, which will give a similar type of oxides and hydrates. Okay, so we have to keep in mind, very important question. They will ask questions from this topic. So according to the Mendeleev period table, according to the Mendeleev period table, silicon will give which type of oxides? Silicon will give a which type of oxides and hydrates? You have to keep in mind. Hydrates. Okay. So silicon will give a R. Silicon will give a RO2 type oxides and will give a RH4 type hydrates. You have to remember this. Definitely you had, so you have to remember this type of. So definitely the last question like this. Okay. Now same way, you will see the oxygen and in this group. Okay. So they will possess RO2 type oxides and RH2 type hydrates. Okay. So they'll give a similar type of. Okay. You see the hydrates of the oxygen and sulfide, both will give a H2O type and H2S type. Okay, both are giving the same type. RH2, where R is the oxygen or sulfur. Okay, RH2 type. See, you can see the same type of hydrates. Okay, so that elements only grouped in one. It made a one group. Okay, so the element which shows a similar properties, he made one group. Okay, so these are the main features of the Mendeleev's periodic table. Here also you can see the periods and columns. Okay. Now same way, we'll go with some more merits and so demerits also there. Here in the Mendeleev periodic table, there are some limitations are there. At the same time, say so many achievements are there. Achievements are there. At the same time, there are some limitations are there. Okay. So main achievement is there. So is somewhat acceptable periodic table. Okay. But here also, so you can see the main features. He left some gaps. Okay. You will see the main merits of this periodic table. Okay. So even you see the merits of this periodic table, first merit is he gave some, he given some space. He left some space for a newly discovered element. He yet not discovered. Okay. For new elements, he given some space. Okay, which are not discovered. And some element he predicted. So some element he predicted and named as a Eka boron, Eka silicon, and Eka aluminum. Okay, so that element is also found. Okay, so some we have to learn some of the merits of the Mendeleev periodic table. Okay, at the same time there are demerits also there. Demerits also there. Okay, you should be learn the demerits also. Okay, so he is unable to give unable to locate the correct position to the, so unable to locate the hydrogen in the periodic table. He is unable to give the correct location to the hydrogen. Why? Because this hydrogen will shows properties like a lithium family, like a alkali metals. Okay, so it will show same type of stuff. They will, hydrogen also will form a same type of oxides. Okay, like a H2O. So lithium also will form a Li2O. Sodium also will form a Li2O. Okay, same type of oxides it possess. Same type of oxides it will possess. Okay, same way. And also show the properties like a halogen family, like a halogens, like a fluorine, like a chlorine, fluorine, bromine. Why? Because this element will be exist in the form of dimeric molecules. These are available in the dimeric molecule, in the molecular form. That is a dimeric, in the form of dimeric molecule. So fluorine exists in the form of F2. Fluorine also exists in the form of Cl2. Bromine also exists in the form of Br2. Same way, hydrogen also exists in the form of H2. This possesses the most properties like a alkali metals, at the same time halogens. Okay, so but he kept it at first grade, but he kept in the simply he kept at with the first group elements, with the first group element. If you see the table, that is there with the first group element. Okay, if you see the table, that is there, this hydrogen is there with the first group. You see here, that is there with the first group. Okay, so he is unable to give a correct position to the hydrogen. That is the next one. Next. So next one is, if you see the next demerit, that is, so if you see the atom, so actually here in the elements is increasing order of atomic mass. Okay. When you see the atomic mass increase, that is not regular. Okay. So atomic mass is not increasing in regular manner. Okay. So because of that, we can't predict the number of elements between the two elements. Okay. If the atomic mass increases in regular manner, we can able to predict the new elements. Okay. The atomic mass is not increasing in regular manner. So we can't predict the number of elements between the two elements. There is one limitation. Okay. At the same time, so there is no place to the isotopes in the actually modern this Mendeleev periodic table based upon the increase in atomic mass. Okay. So there is no space to the isotopes of the elements. So what do you call as isotopes of elements? So what do you call as isotopes of element means the elements which have the atoms of element which have same atomic number or same chemical properties. They have a same chemical properties. So here we don't know the atomic mass. We will see the next case. Okay, what do you call as isotope? Now the atoms of same element have a similar chemical properties, but different mass, different atomic mass, different atomic mass. Okay, for example, hydrogen exists in the three isotopes. Hydrogen atomic, so mass number 1, mass number 2, mass number 3. Okay, protium, and tritium. Okay, these elements. So having same, they will possess same properties, but atomic mass is different. Okay, so there is no space to the isotopes in the Mendeleev periodic table. This is one of the main limitations. Okay, so you have to remember these merits and demerits along with the features of the Mendeleev periodic table. Okay, very important topic. Here they will ask us so many questions. You can expect a maximum at least one question, 2 questions you can expect. Out of 5 marks, you can expect it. Or 2 questions, one mark questions you can expect. Okay. Now next we'll see how they will ask questions from this topic. Okay. We'll see the questions how they will ask from this topic. Okay. First, remember the topic. At the same time, next we'll see how they'll ask question from this topic. Okay. Now, so just I'll see the some questions. So remember some questions. Okay. Yes. You see it. So like one more. So keep aside these options. Okay. Now answer the question. So according to the Mendeleev periodic table, the elements were arranged in the periodic table in the order of just how the elements are arranged in the Mendeleev periodic table in the increasing order of atomic mass. In the increasing order of atomic mass. Okay, this is a thing you have to keep in mind. Yes. You see here, so the totally the Mendeleev periodic table is based upon the here in the elements in increasing order of atomic mass. Okay, that you have to keep in mind. Okay. Next, you will see the next question here. In the Mendeleev periodic table, gap was left for the element to be discovered later. Okay. Which are the following element found a place in the periodic table later? Okay. Out of this element, which element is found later? Okay. That is germanium. Yes or no? So germanium. So not this element. Already these elements are there in the period in the Mendeleev periodic table only. So these elements so only these elements. Okay. So only these elements. Sorry for interruption. Now, you see once again question here. So in the Mendeleev periodic table, so he gave the gap were left for the elements to be discovered later. Okay. So which are the following element? Okay. They may ask like a, they won't ask like a multiple choices, just to remember this question. Okay. From here, like this also they may ask questions. Okay. Now, so actually if you see that, so Mendeleev named some element, unnamed elements and given name like this. Okay. Eka boron, Eka aluminum, and Eka silicon. So later on, Eka boron became a scandium, and Eka aluminum became a gallium. Okay, and Eka silicon became a germanium. Remember this element. So he predicted some elements and named that elements as a Eka aluminum. So first one is Eka boron. Okay, so later on this Eka boron became a scandium. Next element. So Eka aluminum. So later on it became a gallium. Next element. So Eka silicon. So later on this element became a germanium. Okay. So these elements. So he predicted a name. So later on that elements also have a place, got a place in the modern periodic table also. Okay. This is the topic. Okay. Just remember these things. Okay. Next we'll see the next questions. Okay. So this is the way they will ask like questions. Okay. Next one. If you see the next questions. So when move to the next questions. Okay. You see the next question here. Okay. Now, so element have been arranged in the following sequence on the basis of increasing atomic masses. Okay. So this is the element they given to us. Okay. So we have to arrange. So they arrange in the increasing order of atomic mass: fluorine, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium. Okay. So pick up the two set of elements which have similar properties. Okay. Next, first one. What is the first question they ask here? So you have to pick up the two set of elements which have similar properties. Okay. Next, the given sequence represent which law of classification of elements? Okay. Now, you see the first. Okay. You see the when you see these elements. Okay. So out of this, sodium, magnesium, aluminum, silicon are metals. Okay. And fluorine are halogens. Okay. There are two set of elements. Okay. So given set of represent the Mendeleev's periodic table. Okay. So when you see the Mendeleev periodic table, you can see these are the metals, like sodium will be the separate. Okay. And magnesium will be separate. Okay. These are the, okay. This sodium will be in one set. Okay. One group. Sodium and potassium in one group. Okay. And separate group. Magnesium separate. Okay. These are in one group. Halogens group, separate group. Okay. So this set will represent the Mendeleev periodic table. Okay. So based upon the reactivity toward the oxygen. Okay. So this will sodium and potassium, they'll form same type of oxides like a R2O type oxides and RH type hydrates. Okay. Same with magnesium. You see the magnesium, it will form a RO2 type, RO type oxides, and R H2 type hydrates. Okay. Now, when you see the aluminum, so aluminum will form RO3 type oxides, sorry, R2O3 type oxides. Okay. And it form hydrates of RH3 type hydrates. Okay. Now, so when you see the fluorine and fluorine, so they'll form, when you see this fluorine and fluorine, okay, so this you see here, fluorine and fluorine. So this set will be, it form a R2, it form a R2O7 type oxides and RH type hydrates. Okay, this is the separate set will be there. Okay, so we can able to make a set, two sets, set wise. Okay, these are metal, these are the halogens. Okay, they form a same setup. They form a, in each set they will form a same type of oxides and hydrates. Okay, so so like that, the last question from here, you have to remember this. Okay, now, same way. You see the next question here. You see the next question here, second question. So in the Mendeleev periodic table, the elements are arranged in the increasing order of atomic mass. Increasing order of atomic mass. Okay. Now, however, in some cases, so you can see this one in the case of limit cases. Okay. So cobalt atomic mass is 58 point. Cobalt, there is cobalt atomic masses. Cobalt atomic mass is 58.73 AMUs. Okay. So it was placed before the nickel, whose atomic mass is, this one placed before the nickel, and whose atomic mass is 58.71. 58.71. Okay. So why do this? Okay. You see the period table. When you see the Mendeleev's period table. Okay. See here in this period table, just iron. So cobalt, just iron is placed before the cobalt, though its atomic mass is less. Okay. Why? Because just to arrange the elements in the group of similar properties, he made like this. To arrange the elements in the group of similar properties, just he made like this. Okay. Because of this. Okay. This is the one. And also you can see one more here. Okay. Here also aluminum and silicon. Okay. So aluminum and silicon. So aluminum have a more atomic mass when compared to silicon. So just you have to keep in the group of similar properties. Just he made reverse order. Okay. Here you can see the reverse order. Okay. And you can see the one more reverse order. So here you can see the one more reverse order. Okay. Tellurium and iodine. Okay. So tellurium having a 127 atomic mass and iodine have 126 atomic mass. Here also you can see the some reverse arrangement. Okay. Why he kept that? Just to keep the elements in the similar group. To keep the elements in the group of similar properties. Okay, that's the one main motive. His motive is that, so just to keep the elements in the group of similar properties. That's why he kept like this. So you have to write this reason. Okay, now, so either way, so the last questions from the Mendeleev's periodic table. Mendeleev's periodic table. Okay, next. We'll see some more questions. Okay, we'll see some more extra questions from here. Okay, now. You can see some more questions here. Okay. So write the chemical formula of chloride. Write the chemical formula of chloride. Okay. Chemical formula of chloride of Eka silicon and Eka aluminum. Okay. And the elements created in the Mendeleev by the Mendeleev. Okay. So already I said. So Eka boron became a scandium. Eka silicon became a germanium. Okay. So this became a. Okay, so already I told. You see here. So already told here. So Eka boron became a scandium, Eka aluminum became a gallium, and Eka silicon became a germanium. Okay. So this Eka scandium. Okay. So it belongs to the first group. So that it belongs to the second group. Okay. So gallium belongs to the, that is 13th group, and the family of boron family, and the boron family, boron, aluminum, gallium. Okay. So this element will possess they will possess a, so they'll form which type of oxides na? A2O3 type oxides, and they will form a chlorides of, it's not like this, okay, R2O3 type oxides, and they will form a RCl3 type chlorides. Okay, so all this group. Next, same way, ecosilicon. Ecosilicon is the germanium. Okay, so it is a family of, later on it became a family of carbon, carbon, silicon, germanium. Okay, so they will form a RO2 type oxides, RH4 type hydrides, or X4 type halides also. They will form a RX. Okay. Now see them. Now see the question. What they ask us. Okay. You see? You see the question here. Now they're asking a simple question here. So write the formula of chlorides of Eka silicon and Eka aluminum. So the element predicted by the Mendeleev. Okay. So already told. So Eka silicon later on became a germanium. This became a germanium. It became a ECl4 chlorides. Okay. So Eka aluminum later on became a gallium. Became a gallium. So it will form ECl3 type halides. Okay. Halides. Remember this. Okay. So this is the way they will ask questions from here. So just remember the way they are asking the questions. Okay. Next, you will see the next question here. When you see the next question, now, so here, so Mendeleev predicted the existence of the certain elements not known at the time, named. So name two of them as Eka silicon and Eka aluminum. Okay. So name the elements which have taken the place of the elements. Okay. So already we said, so it is Eka silicon replaced by the germanium and Eka aluminum replaced by the gallium. That's we know. Okay, next one. So mention the group and period of these elements in the modern periodic table. Just means we need to compare with this with, okay. So gallium will come to the germanium will go to the group of 14 and period 4. Okay. And gallium will go to the group 13 and period 14. Period 14. Okay. So I'll show that. I'll show that where it is. Okay. By taking the you see the periodic table. Okay. So when you see the modern periodic table, so here you can see the elements. This one. Okay. So gallium 1. So these are gallium and these are germanium. Okay. So they are belongs to the fourth group, fourth period. This is the fourth period, and belongs to the 13th and 14th group. 13th and 14th. Okay. So now, so that sometime they will ask question. They will ask question by comparing with the modern periodic. Okay. So we should be thorough with the modern periodic table also. Okay. Now, next question. So you see the next question what they ask. Okay. So mention the group and period of these elements in the modern periodic table. Yes. Next. Classify these elements as the metals and non-metals. Already we know. So germanium is a metallite and gallium is a metal. Okay. And how many valence electron present in each of them? Yes, we know. So we learn more about this valences of the groups and periods, groups of the each group of the elements. We can see later that already we know. The first group element. Okay, actually they belongs to the 13th and 14th group now. Okay, so 14th germanium is the 14th group element. That's why it possesses the 4 valence electrons, and gallium became a 13th group element. It will possess a 3 valence electrons. Okay, so this is the way they will ask questions from the Mendeleev periodic table. Mendeleev's periodic table. Okay. Now this is the way they'll ask questions. So this is the way they'll ask questions from the each topic of the. We covered 3 topics. That is First topic is Dobenier triad. We saw the what he called as Dobenier triad, how the last question from the Dobenier triad. Next, we covered the Newland's law of active. Then we saw the how the last question from the Newland's law of active. So we should be thorough with the limitations and features of the Newland's law of active. So next we covered the Mendeleev periodic table, and we saw that some questions how the last question from this Mendeleev periodic table. You should be thorough with the merits and demerits of the Mendeleev's periodic table. Okay, and also check the questions. These are the last questions. Okay, and we should be thorough with the Mendeleev periodic table. Okay, so in the Mendeleev periodic table, just arrange the elements in increasing order of atomic mass. At the same time, he grouped the elements. The element which possess the same type of chemical reactivity toward the oxygen and hydrogen. Okay, that element is kept in the one group. Okay, so this is about the first part. Then the second part, we'll see the total modern periodic table. Okay, thank you. Have a nice day.